In the previous lecture, we learned the derivatives for a multivariable function, which is also called the partial derivatives. In this lecture, let's talk about the interpretation of partial derivatives. Suppose we have a function of two variables, z equals to f of x and y. Then we can draw this function on an xyz coordinate system as a surface. And let's call this surface S. Then at the point x equals to a and y equals to b, the level of the surface will be f of a and b, and let's call this value c. Then the surface S will contain this point with coordinates a, b, and c. And let's define two curves. C1 is the intersection curve of the surface and the plane y equals to b. So that corresponds to this curve here, that is along the surface, and y is a constant, y equals to b. And we'll define another curve, C2, as the intersection curve of the surface and the plane x equals to a. So that is shown here. Then, the partial derivatives fx and fy, which are the partial derivative with respect to x and with respect to y, at this point, a and b, we can interpret them as the slope of these two curves, C1 and C2, at this point. So the partial derivative with respect to x at point a and b is the slope of the tangent line at this point, at point P, with coordinates a, b, and c. And the partial derivative of the function with respect to y at a and b will be the slope of the tangent line of the curve C2 at point a, b, and c. Now let's look at this example. If the function f is a function of two variables, and the rule is 4 minus x squared minus 2 times y squared, find the partial derivative with respect to x and y at the point 1 and 1, and interpret these numbers as slopes. Let's first find the partial derivative functions. The partial derivative with respect to x as a function of x and y is the derivative of the function f by treating y as a constant. So we get negative 2x, and the 4 and negative 2 times y squared are just some constant, so their derivative is 0. How about the partial derivative with respect to y? Then we treat the x as the constant, and we get negative 4y. Then we substitute the point 1 and 1. We get the partial derivative with respect to x at 1 and 1 equals to negative 2, and the partial derivative with respect to y at the point 1 and 1 equals to negative 4. Then using what we just learned, we can interpret these two values, negative 2 and negative 4, as the slope of the tangent line of curves C1 and C2, where C1 is the intersection curve of the surface and y equals to 1. And C2 is the intersection curve of the surface with the plane x equals to 1. Here it shows the surface of f of x and y. If we substitute the point 1 and 1 into the function, we'll get a positive 1. That means this surface contains the point 1, 1, and 1. So C1 is the intersection curve, which is this curved line, between this surface and y equals to 1. And the tangent line at this point is the purple line shown here. And from what we just learned, this tangent line has a slope of negative 2. Similarly for the partial derivative with respect to y. So C2, which is the blue curve, that is the intersection curve of the surface and the plane x equals to 1. And at this point, 1, 1, and 1, we can draw a tangent line on C2 at point 1, 1, and 1. And we found that the partial derivative with respect to y at this point is negative 4, which means this purple line, which is the tangent line at this point of C2, it has a slope of negative 4. And that is the end of the lecture. In the next lecture, let's talk about higher derivatives of multivariable functions.